My today's topic is corona. In transmission line, when the applied voltage cross a certain value called critical disruptive voltage, the conductors are surrounded by a faint violet glow with hissing sound and slight vibration with known as corona. When an alternating potential difference is applied across the two conductors whose spacing is large as compared to their diameters, there is no apparent change in the condition of the atmospheric air surrounding the wire if the applied voltage is low. However, when the applied voltage crosses a certain value, which is called critical disruptive voltage, the conductors are surrounded by a faint violet glow, and this is the main function of the corona. The phenomenon of corona is occurred by hissing sound, producing ozone gas, power loss, and the radio interference with slight vibration. The higher the voltage is raised, the larger and the higher of luminous effect is developed, and greater the sound and the power loss of the is also greater. If the applied voltage is increased to the breakdown value, a flashover will occur between the conductor due to the breakdown of the air insulations. If the conductors are polished and smooth, the corona glow will be uniform throughout the length of the conductor. Otherwise, the rough points will appear brighter. With DC voltage, there is difference in the appearance of two wires. The positive wires has uniform glow about it, while the negative conductor has spotty glow. Now, what is the critical disruptive voltage? It is the maximum phase to neutral voltage at which the corona occurs. Consider two conductors of radius r cm and the space between them is d centimeter apart. If the V is the phase to neutral potential, therefore the potential gradient at the conductor surface is given by G equals to V by R log E d by R volt per centimeter. In order that the corona is developed, the value of G must be made equal to the breakdown strength of the air. We know the breakdown strength of air is 21.2 kb per centimeters, and this is denoted by G0. Then the required phase to neutral potential Vc. Therefore, G0 equals to Vc divided by R log E d by R, where G0 is the breakdown strength of the air, that is equals to 21.2 kb per centimeters. So the critical disruptive voltage Vc equals to G0 into R log E d by R. Now the visual critical voltage. And what is visual critical voltage? It is the minimum phase to neutral voltage at which the corona glow appear all along the wire of the conductor. In case of parallel conductors, the corona glow does not being at the disruptive voltage Vc, but at the higher voltage Vv, called the critical visual voltage. The phase to neutral effective value of visual critical voltage is given by the following expression of the formula: Vv equals to mv into G0 into del R into 1 plus 0.3 divided by root over of del R into log E d by R kV per phase, where mv is the another irregularity factor having a value of 1 for polished conductor and for 0.7 to 0.72 to 0.82 for rough conductor. Now, the principle of corona formation. Some ionization is always present in air due to the cosmic ray, ultraviolet radiation, and radioactivities. Therefore, under normal condition, the air around the conductor contain some ionized particle. like free electrons and positive ions and neutral molecules. When potential difference is applied between the conductor, the potential gradient is set up in the air, which will have the maximum value of the conductor surface. Under this influence of potential gradient, the existing free electrons acquire greater velocities. The greater the applied voltage, the greater the potential gradient, and more is the velocity of the electrons. When the potential gradient at the conductor surface reaches about 30 kV per centimeter, that is the maximum value, the velocity by the free electron is sufficient to strike the neutral molecule with enough force to dislocate one or more electrons from it. The production of another ion and one or more free electrons, which is turned the accelerated until they collide with another neutral molecules, thus producing other ions. Thus, the process of the ionization is cumulative. The result is that the corona occurs due to the phenomena. Now, the factors affecting corona. The phenomena of corona is affected by the physical state of the atmosphere as well as by the condition of the lines. The following factors are related with the corona. First one is the physical state of atmosphere. As corona is formed due to the ionization of surrounding the conductors, therefore it is affected by the physical state of the atmosphere. Next one is the size of the conductor. The corona effect depends upon the shape of the condition of the conductors. The rough and irregular surface will give rise to more corona because ununiformity of the surface decreases the value of the breakdown voltage. Thus, standard conductor has regular surface and hence give rise the more corona than solid conductors. Now, spacing between the two conductors. If the spacing between the conductor is made very large as compared to their diameter, there may not any corona effect. It is because large distance between the conductor reduce the electrostatic stress at the conductor surface, thus avoiding corona effect. Next one is the line voltage. The line voltage greatly affects corona. If it is low, there is no change in the condition of the surrounding the conductors and hence no corona is developed. However, if the line voltage has such a value that electrostatic stress developed at the conductor surface make the air around the conductor conducting and corona is developed. Now, the effect of corona. There are some effect due to the corona. First one, a faint violet glow appears surrounding the conductor which is visible at the dark situations. That means at night period, corona is clearly visible in high voltage transmission lines. Next point, a hissing sound is generated in the surrounding area. Next point, the conductor tends to vibrate. There will be slight vibration occurs when the corona is developed. Next, ozone and oxide of the nitrogens are produced. Next point, there will be some power loss associated with the corona because electrical power consumed by the producing sound, by the producing vibration, by the producing faint violet light, etc. So there will be huge power loss due to the corona. Next point, the formation of corona creates radio interference. Some radio interference is also present due to the corona effect. Next, power loss due to the corona. Due to corona effect, some amount of power loss will be developed, which is radiate in the form of light, heat, sound, vibration, chemical action, etc. When the disruptive voltage is crossed the normal voltage, then the power loss due to the corona P equals to 242.2 into 8 by plus 25 divided by delta into root over of R by D into V minus Vc square into 10 to the power minus 5 kilowatt per kilometer per phase. That is the value of power loss corona. Now the advantages of corona. Corona has many advantages and disadvantages. So the advantages are, due to the corona formation, the air surrounding the conductors become conducting, and hence virtual diameter of the conductor is increased. The increased diameter reduces the electrostatic stress between the conductors. Next advantage is that corona reduces the effect of transient produced in the surge. There are a lot of disadvantages of the corona. First one, corona is generate a huge amount of energy loss. This affects the transmission efficiency of the line, because we know losses are inversely proportional to the efficiency. Due to the corona, there will be huge power loss due to the production of light, production of sound, production of vibrations, etc. So due to the losses, the efficiency of the transmission system will be minimum. So corona is not a good effect, that is the bad effect. Next point, ozone is produced by the corona and may cause the corrosion of the conductor due to the chemical action, and as a result the surface of the conductor get damaged. Next point, the current drawn by the line due to the corona is non-sinusoidal, and hence the non-sinusoidal voltage will be occurs by it. Now the method of reducing the corona. It has been seen that the effect of corona is obviously affect the system badly. So the corona effect can be reduced by the help of the following methods. One is by increasing the conductor size. By increasing the conductor size, the voltage at which the corona occurs is raised, and hence the corona effects are considerably reduced. This is one of the reason of that ACSR conductor, that means aluminum conductor steel reinforced, which have the longer cross-sectional area and used in transmission line. So previous classes we already know that about the ACSR, that means aluminum conductor steel reinforced. This is the special purpose transmission wire where the reinforcement system is developed. The outside of the system is designed with the aluminum conductor which is used as the conducting material, and the middle portion is inside the middle portion a steel conductor is placed which gives the tensile strength. So if we use this type of conductor, then corona effect can be minimized. Now by increasing the conductor spacing, by increasing the spacing between the conductors, the voltage at which the corona occurs is raised, and hence the corona effect can be eliminated. However, the spacing cannot be increased too much, otherwise the cost of the supporting structure may be increased rapidly. Because if we try to maintain the distance between the two conductors, then the height of the tower will be increased, and as well as the cost of the tower will also increase. Now, a problem related with the corona. A 3-phase 220 volt 50 Hz transmission line consists of 1.5 centimeter radius conductor spacing 2 meters apart in equilateral triangular formation. If the temperature is 40 degree and the atmospheric pressure is 76 centimeter, calculate the corona loss per kilometer of the line. Take m0 equals to 8.5. Now this is the solution. Corona loss is given by P equals to 24.2 divided by delta plus F plus 25 into F plus 25, that is into root over of R by D into V minus DC square into 10 to the power minus 5 kilowatt per kilometer per phase. Here delta equals to 3.92 B divided by 273 plus T, that is equals to 3.92 into 76 divided by 273 plus 40, and that is equals to 0.952. So that is the value of delta. Let Z0 equals to 21.2 kV per centimeter RMS. Therefore, critical disruptive voltage per phase is Vc equals to M0 into Z0 into delta into R into log E d by R kV, and that is equals to, if we put in the value of all the parameters, then the value of Vc, that means critical disruptive voltage, equals to 1.25.9 kV. Now supply voltage per phase V equals to 220 divided by root 2, that is equals to 127 kV. Now the substituting the above values, the corona losses as, if we put in the all values, then the value of the losses is equals to 0.01999 kilowatt per kilometer per phase, that is equals to P. The total corona loss per kilometer for the 3 phase, that is equals to 3 into 0.1999, that is equals to 0.05998 kilowatt, and that is the final answer.